Welcome back to my channel. So today I'm going to show you how to select rows and columns in R. So right now we are in the RStudio environment and I have prepared the code here for you. First of all, let's run the first two lines to get the data. This is a very simple data with height, weight, and age. So after you select these two rows and then you click Run, and then you will get a data set. It's a data frame format with 3 columns, height, weight, and age. You can close it. So first command is you select all the rows and all the columns. You just call bracket blank, comma, blank. So meaning you will select every element from all the rows and every element of all the columns, basically everything from the data set you set up. So after you click this command, it will show you the complete data set here in the console. Now the second one, if you just want to have the first row, the 183, 175, and 178. Oh, this is kind of insane. Like nobody can live up to 178. But anyway, probably this is in days. So if you want to choose the first row and everything from all the 3 columns, you do bracket 1, comma, blank. So that is the first row with all the columns. Let's run this. Now you get just this vector of the first row. So similarly, if you want to select first 2 rows, you will do bracket 1, colon 2. So meaning first 2 rows and then everything from the column. So you leave it blank, meaning you will select all the columns. So you will get this first 2 rows. Okay, so what if you wanted to choose the first and the third row and skip the second one? You will do a concatenation with C bracket 1 and 3. So then you will skip the second row and also everything from the column. Now you get the first and the third column. Okay, so now we can do some operations on the columns. If you want to choose first row and also the second column and the third column, you can do bracket 1, comma 2, colon 3. So this will give you the first row and also the last 2 columns. See? So now you only have weight and age show up with the first row. And next one we will have first and second row and also second and third column. So this will be an easy task for you. So let's do a check. We got the first 2 rows correct and the last 2 columns. Nice. And now you want to get the first column with all the rows. You just do bracket blank everything from the rows and the first column. So this will give you a vector 183, 85, 40, but they put it in a row. Actually, this is the first column you selected. 183, 85, and 40 for all the heights. And then if you want to select the first and third column with every row, so then you will show height and age with all the rows with this command. Height and age with all the rows. Yeah, I hope you learned something from this short video. Hello everyone, welcome back to my channel. Today I'm gonna show you how to use R as a simple calculator. You can use it for addition, subtraction, multiplication, division, square root, and also you can generate random numbers. So let me show you these examples here. First is the addition. So you can just put the numbers with a plus between them and you run it, and it will give you the results directly. So it's very straightforward to use it as a calculator. So similarly, you use it for subtraction. You just run it directly and you will return the number for you. And for multiplication, you use a star in between the two numbers. This is 12 times 12. It will give you 144. And then for division, you use a slash in between these two numbers, and you will get the results directly. So these are easy commands. And then for square root, you can do sqrt bracket with the numbers. Let's try 16. So this will give you 4. So this is also easy. And then for generating a random number, usually we use the function called rnorm with the bracket 4. 4 is the number of random number you want to generate. By default, the random number is from the normal distribution with mean 0 and standard deviation 1. So if you don't specify these two parameters, it means you are drawing random number from a normal distribution with these parameters. So if you run this, you will get 4 random numbers. And however, each time you run it, it will give you different 4 numbers because they're random, unless you set the seeds. But we can cover that topic in another video. So after you specify the mean and standard deviation, you will see the numbers are changing around the mean. So for this, we bump up to be 50. So the numbers are within the range of 10 of 50. And also you can generate like 400 numbers with the same mean and standard deviation and draw a histogram. So we assign these numbers into a vector, and then you plot that vector. So let's run this. So this will give you a normal distribution with a mean of 50 and standard deviation of 10. So I hope you enjoyed this video and learned something. Today I'm gonna show you how to use seed when you generate random number. So let's generate 25 random number from a normal distribution with a mean 0 and standard deviation 1. Let's comment out the seed first, and we generate 100 random number with a mean 100 and standard deviation of 15. And this is the histogram and also a summary. And then we try to run a small sample. We set seed for 5 random number, and if you run this 5 random number, it will always be the same. But if you don't set the seed, the random number will always be different. Now let's look at this 100 random number. If you set the seeds, the summary will always be the same. And also, the histogram will never change. However, if you comment out the set seed function, the histogram is always changing because the numbers are random. So each time you get different results. Today, I would like to show you how to use pipe operator in R. So what is it? In R, the pipe operator is % greater %. So this sign, if you are not familiar with F#, you can think of this operator as being similar to the plus in a ggplot2 statement. Its function is very similar to that one that you have seen of the F# operator. It takes the output of one statement and makes it the input of the next statement. When describing it, you can think of it as a then. Now let's go back to RStudio. First of all, you need to download dplyr. So I've already installed dplyr here in this environment. We can run dplyr directly. So call the library for dplyr. And then we can try to compute the logarithm of x. If we assign 100 to x, and then you run the function for log, you will get 4.6. And similarly, you will get the same results actually using the pipe operator with the x at the beginning and then percent greater percent with log function. So this two statement is equivalent. Next, we can try the round function. You put pi and round up to be 6 digits, round up to be 6 decimal place. And using the pipe operator, you get the same result. So these are just single basic piping. And then I think it will give you the advantage of a cleaner code when you have a more complex argument. We can try to manipulate a data. So we have a data called baby names. So these are the baby names from the United States. Let's call this library and show you the data. We have 5 columns here: the year, the sex, the baby names, and also the counts and proportion. So now let's do some operation on this data set. We will filter the baby names based on their sex will be male, and then name equals to Taylor, and also select the variable n, the count, and do a sum over this variable. So this is the task we're going to perform on this data set. Let's run this command. So you will get about 109,852 number of male babies named Taylor. So since this is a very long statement, we wanted to break down it into single functions for the operation that we did for the baby names. The baby names is the data that we wanted to operate on. So the first function is filter, and we will set these two conditions. And then the next function is select the variable that we will do the summary statistic. The last function is the sum over the variable that we selected. So this statements, this piece of code that using the pipe operator will return the same result as the one we write in one row, but it will look more clear. So I hope you learned something out of this video. The other day I encountered an issue called package or namespace load failed for dplyr to call the library for dplyr. And then I searched this error message online and find this web page, and people are also discussing the solutions for resolving this issue. So it's probably that another package is not installed, or the version is not compatible with the current dplyr package. So I go back to my console and call dplyr package, and then I find out the package missing is called vctrs. So I will install this package and see if this can fix this issue. So after I installed it and rerun the call library, and it works. And hope this video can offer some help when you encounter a similar issue for dplyr package. Today I'm going to show you how to transpose a dataset. So there are 2 different ways I'm going to show you today. The first way is a more traditional way of transposing rows and columns. Let's use the empty cars as an example. So for this way, you need to call the library called data.table. So let's call this library and also get the data for empty cards. So this data set looks like this with cars for each row and all the parameters for each column. So now you use transpose function to put the original data set in the brackets, and the new data set we rename it with the t_ empty cards. So now let's take a look at the structure of the new data set. So it may look a little intimidating because all of the variable names are renamed to be v with a number, the vector, and also 11 rows. So this 11 rows actually corresponding to the previous 11 columns, and each column is now turning to each rows are now turning to columns. So we need to swap the names for the rows and columns. So this will do the trick. So you use the row name from the original data set to assign it to the new data set's column name, and also vice versa. So let's do these two commands, and then we take a look at the transpose data set. So now it's much better. So we have the column name as the car name for different brand, and for each row it's the parameters. So now you fulfill the function for transposing a data set. Another way of doing it is called spread function and gather function. So gather is more like stacking the data together, and spread is making it to be wide format. So this function is coming from the tidyr package. So let's call these two packages, since we need to use the pipe operator from the dplyr. Or you can use tidyverse to call all of them in one shot. So we will use a simulated data set called stock. So assuming we have the time point, and this is the price of the three stocks, one X, Y, Z. So this data set looks like this. Now we wanted to make it like a long format. So it's we call gather stock and also price and by time. So then we will get a long format of the stock summary. So we have the stock as a column, price as another column, and in stock we have three values, X, Y, Z. Then you can see the stock and price are the two columns of the data set with three stocks, and the price is ordered by time point. So let's go back to the code. And now we can use the spread function using stock as the key and price is the value. So as you can see from the console, the stock is the column. For each stock has a column, and the variable time did not show up in this function, but it will be serving as the identifier for each row. You can also spread it using time as a key. So we're spreading the price, the value for each stock by over time. So whatever variable you put first, it will become the column in the new data set. I hope this video offers some help. So recently I noticed some of my videos that about the R programming is getting a lot of views. So thank you for stopping by my channel and look at those videos. I'm glad that I offered a little help to you. So today I'm going to show you a very simple program to run linear regression in R. So there's only 4 lines of code, as you can see from the screen. So we will load the data first. So empty cars, everybody knows this data set. And then after we use attach, it will attach all the variables into the space. So when you call the variable, you don't have to attach the dataset name with the $sign anymore. So we can use the variable name directly. So for linear regression, we will use the lm function, and then we assign it to an object. And then all the results running from the model will be assigned into the lm1 as an object. So let's run this line of code. After that, we got this model here, and here contains all the information you need. So we will use the summary function to call the results, and you will have a nicer display of all the results here. So here is all the information you need from a simple linear regression. So we have intercept and the as an alpha, and also the beta, or sometimes we call it beta 0 or beta 1. So the estimate for the intercept is about 37.88, and then the coefficient for cylinder is negative 2.8758. So this meaning is when you have more cylinders in your car, your mileage will go down. So with the negative sign for the coefficient, and also this variable is significant. So out of this model, you will learn that the cylinder is a significant predictor of the mileage of a car. So I hope you learned something from this little simple video about the simple linear regression. We can dive deeper in future videos if you are interested in other topics using R for either programming, data cleaning, or statistic related topics. Thank you for stopping by, and we'll see you in the next video. Today I'm going to show you a very neat package called tidyquant. So together I will use the ggplot2 and also dplyr to show you how to get a very simple minimal look plot out of different stocks. I've already installed these packages, so if you want to follow me with this program, you need to install them. Okay, so let's call these three libraries. Now, so basically the function I'm going to use is called tqget. We can take a look at the help document before you get started. So for this function, we can use get equals the stock prices, and also x is a vector that you will pull in with different stock names. So usually we will pull the stock tick mark. So there are other options here as well, like dividends, splits, or stock.prices.japan. Okay, let's try this example. So we will use get equals stocks.prices, and using from equal to a date and to equal to end date. So these will define the time window you want to look at the stock prices. Okay, now you have this data set here with first column is symbol with Google and also Tesla. So these are all the records. We have more than 5,000 observations within a certain time window. So these are the dates. It is sorted and with several columns of different prices like open, close, high, and low, and also the total volume for the transactions. So now let's plot these two stocks over this time period. So we specified almost a 10 years window. So you can always change a start date or end date to zoom in or zoom out. Now, so you will have two different colors which corresponding to these two different symbols of the stock. And on the x-axis is the date of each different stock prices, And y-axis, we choose the open price for each day. So that's a single number for a day. We can definitely use other numeric variables to put it on the y-axis. So this is just giving you a simple example. So now we can also zoom in like within the 6 months of this year. So the two lines will be relatively flatter than over 10 years. Or we can start from 2020. Take a look at this curve. So as you can see, there's a dip at the beginning of the pandemic, and then with inflation goes up and the stock market goes up, and recently has a slightly dip due to the interest rate hikes. I hope you enjoy this video, and please leave your comments below and tell me what other R programming videos or R packages you wanted to see, and also share your ideas so we can learn from each other. So today I'd like to introduce you to a new package. I came across this GT summary package recently, and I find it's very handy and will give you a very nice layout of the table, so you don't have to manually work on your table anymore out of the R output. So let's load this package first. So today I make the font size larger because I received some comments about my previous videos that the font size is too small. So sorry about that. And also we need to use the dplyr package because we will use the pipe operator today. So the data set we gonna use is called trial. So let's take a look at the data sets. So we have treatment column and age, and grade is the disease severity, and response of the tumor, and also death. So we can do a simple summary using the table underscore summary. So with the pipe operator, you're connecting several actions together. So let's do this part first. So this will give you a nice little summary of overall chemotherapy treatment, drug A, drug B, and also the average age with the range and the grade of the severity. We can also do by treatment group. So this will look like this. So we will have two columns. There's a warning message here. So format missing. So this one, we can revisit this later. And also this adding another function is the p-value. Okay, so this format missing function is still showing up in the warning message. With adding the p-value column, you get the p-value for these two variables between these two treatments. Okay, now let's run a more complicated. Now let's run more complex code. So we are adding the overall p-value and also modify the header. Do some modification to the headers and add a caption for this table. So this code will give us a bigger table. Yeah, so we will have the variables and the big N column, overall column, and then drug A, drug B, and then p-value. So the variables and the table header are bold color. And so this will give you a really nice layout of a table, and you can copy this picture directly to your presentation slides. So that's the package I'd like to introduce you today. So we will look into the format missing function next time. Thank you for stopping by and thank you for watching this video. I will see you in my next video. Bye.